Welcome back. In this video, I'm going to be talking about virtual inheritance and the usage of virtual base classes. Let's look at the hierarchy that I've got here. I have a base class animal, and then I have two children, bear and raccoon. Both these classes publicly derive from animal. Now, what makes it interesting is that I've got another class, panda, which derives both from bear and raccoon, because a panda is both a bear and also considered a type of raccoon. So if you draw this hierarchy out, you're going to get like a diamond structure. And the problem with this is that since panda derives both from bear and raccoon, it's going to contain a bear subobject and a raccoon subobject. Now, each of these classes in turn derive from animal, and they are going to contain their own copies of weight and height. So panda would eventually end up with at least two copies of weight and height, one from the bear subobject and the other from the raccoon subobject. Now, this is a pedagogical example, but in reality, if you consider the usage of maybe a single memory buffer and your target class is going to inherit two copies of the buffer, you're going to be in trouble. You always would want to have probably maybe a single copy of the buffer, or you might want to maintain a condition variable which gives you the state of your object. So you're not going to be very happy if you have multiple state variables, right? So how do you overcome this problem? All that you need to do, and C++ provides this functionality out of the box. So it allows you to declare something called as a virtual base class. So for instance, bear and raccoon can always say that they're going to share a single object as their base class object. So we get something called as a virtual base class, and all that we need to do is that you need to say virtual public animal and virtual public animal here. So both these direct children now have a virtual base class, and the virtual base class is the animal class. Now the order of the words virtual and public do not matter. You can always say public virtual or virtual public. It really doesn't matter. So now that you have done this, virtual keyword has been brought in, and you have sort of declared animal to be a virtual base class. Panda is going to get only a single copy of this animal subobject. So even though it has the derivation from bear and it also derives from raccoon, you're going to have only a single subobject, which will be the animal subobject. All right, so what usually happens with multiple inheritance, or like when you are supposed to when you're supposed to initialize objects, you would start by initializing your immediate base classes. So if virtual base classes were not in play, and virtual inheritance was not going to be used, Panda would only be able to call its direct base class constructors. So it would only be able to call bear's constructor and raccoon's constructor. But since now we are using virtual base classes, that doesn't work because we can't be calling the virtual base class constructor twice, right? So the only difference here is that Panda directly calls its virtual base class constructor. So animal's constructor is called here, followed by the bear constructor and the raccoon constructor. And of course, any non-static member variables are initialized as part of the Panda constructor. So that's all you need to know with regards to the mechanism as to how this virtual base class can be initialized. And this is virtual inheritance. Now, one thing you need to bear in mind is that virtual base classes are always constructed first. So if you got a hierarchy like this with virtual base classes and non-virtual base classes, it's always the virtual base class that is constructed first. So even though you do not have that listed out here in the derivation list, if the compiler detects that there is a virtual base class, that's what gets the construct of the virtual base class gets called first. So always virtual base classes are constructed first. And if you have multiple virtual base classes, the order is usually from left to right. So that's about it. Let's now quickly run this program. I have a simple display function here, which actually is able to take all the variables, the member variables from the various base classes and the virtual base class, and I'm able to get an output here. So let's run this program and see what we get as output. Okay, so let's quickly scroll down to our function. So, my display function says um, let me start from here. So I've initialized my object to have the values 200 for weight, 170 for height, and the color red, or the type of the panda is red. Pandas are of course red and giant pandas. So this panda that I'm creating is a red panda. It's got a wheat complexion, and of course it's 8 years young. So that's what I display here. And as you can see, let's look at the output. So my wheat complexion panda weighs 200 pounds, is 170 centimeters tall. It's a red panda, which is 8 years young. All right. Don't hold me to the specifics of pandas. I'm not an expert on pandas. So, you could have a red panda, which is wheat complexioned in my course, but I do not know whether it really exists in the outside world. But let me quickly go over, what happens here. So when you try and create this my panda object, the first constructor that's called, as I said, is the virtual base class constructor. So the animal constructor gets called. All right, and that's created first, followed by a call to the constructor which is first in the derivation list. So the back constructor gets called next, and thereafter you have a call to the raccoon constructor which gets called next, and finally the non-member variable, the non-static member variables of panda get initialized. So that's what happens when it comes to the construction of the object. Destruction is of course in reverse. So whatever happens in construction, it happens exactly in reverse when the object is being destroyed. So this is virtual inheritance and virtual base classes. It's a pretty powerful and useful concept. You need to actually sit down and think where the virtual inheritance comes in useful for your projects, because there's a lot involved in deciding whether you're going to have like a virtual base class, and does it make sense to actually virtually inherit from a base class. So that's it folks for this video, and as usual, if you have any questions, let me know, and I'll be happy to see you in the next video. Thank you.